This is CS1101 Lecture 13.2. We're going to be continuing our discussion of objects, specifically moving into continuing to discuss multiple levels of inheritance and polymorphism. So now we're taking it the next step. We have derived the class student from the class person. Now we need to derive the class undergraduate from this derived class student. So class undergraduate will have all of the instance variables and methods of the class student, which has all of the instance variables and methods of class person. So to keep everything simple, let's only have each undergraduate contain an int for their current level, their current year. So 0 for freshman through 3 for senior. So this undergraduate class might look something like this. Public class undergraduate extends student. So now undergraduate is inheriting from the class student. So we are declaring the instance variable level, and we have it encapsulated, so we're going to have set and get methods for level. And this is added to what has been inherited from student, which has everything it inherited from person. We need to add a default constructor for our undergraduate class. We will initialize level to 0, and we will call the super constructor. So this will call the constructor in the student class. We'll have a second undergraduate constructor. So this is an overloaded constructor, which will have 3 parameters, name, ID, and level, so that we can set the level and then call the constructor, which is part of the super class, the student class, that takes 2 parameters, a name and student ID. So these are our constructors for the undergraduate class, and we can tell because the undergraduate class is called undergraduate, and our constructor is called undergraduate. And it's overloaded because we have 2 methods here with the same name, but a different set of parameters. Then in both of these, we're making calls to the super class constructor, in this case, the student constructor, which in turn, if you remember, calls the person constructor. And then we have the setLevelMutator method, which takes in a parameter called level, and as long as this parameter is greater than or equal to 1 and less than or equal to 4, so this is an adjustment, right? So we previously said we were going to use from 0 to 3, but that was a mistake. We're going to use 1 to 4. So as long as it's in the valid range, then we will assign the parameter level, the value which is in the parameter level, to the instance variable level, which is a part of the implicit parameter object that we're explicitly referring to using this. So this is what I was talking about previously. One of the benefits of these mutator methods is that we can do validation, right? So if we allowed someone to directly access the level instance variable from outside of this class in a client program, they could write any integer they want into this field. However, by using this mutator method, we're able to validate and say, no, the parameter has to be between 1 and 4 to represent a valid undergraduate year. And if it's not, we will throw an illegal argument exception. So if this value, which is passed in this level parameter, is outside of this valid range, we will throw this exception. However, if it's inside the range, then we will assign the value level to the instance variable level, which is part of the undergraduate class. Further, we have the accessor method for level, so it returns the level instance variable. then we have the overloaded reset. So remember, we had a reset, which was part of the student class. So here we have a new reset method, which has the same return type, name, and then different parameter set. Okay? So this is not an override, this is an overload. So we keep the previous reset. So if we were to pass the name and ID only to the method called reset, it would use the reset method, which is part of the student class. However, we are also able to pass the name, ID, and level, which we'll call this new overloaded reset method. And we see that here as well. So we can, inside this reset method, call the reset method, which is part of the student class, which is the super class. So we could also access this by saying super.reset. But since it's overloaded, then we are able to directly call it just saying reset. And Java knows which reset we're talking about because the parameter list is not the same as this parameter list. So it knows which of the available reset methods we intend it to call. And then we set the level to whatever level was passed in. So what we have defined thus far is a person class, then a student class which extends the person class, and now we have further defined an undergraduate class which extends the student class. So this is the inheritance hierarchy. In each of these rectangles we have the data in green and then the behaviors in gray. So notice, even though now undergraduate contains significantly more than person, because it also contains what was added in student and what was added in the undergraduate class, it's not dramatically larger than the rectangle for person because we are only incrementally growing and incrementally extending each of these classes. So what was added at the undergraduate level to the data was the level. But undergraduate also, since it extends student, has the student number, and since student extends person, it also has name. The same thing is true of the methods. So since undergraduate extends student, it not only has these methods, but it also has all of the methods from the superclass, as well as all of the methods from the superclass for the student class as well. So here's a mini exercise to check your comprehension. It is good to pause this and think about the answer, but you don't have to write it down. But see if you can figure out why we have to use the super to call the toString method in this statement. The answer is because we are overriding the toString method, not overloading it. So this is the new toString method in our subclass. So in our undergraduate class, we are replacing the toString method from the student class with this new method. So if we were to call toString without referring explicitly to the superclass inside this method, we would actually be calling our own method. We would be calling the method which we're already in. And that's something we can do, and Java will do it. And it will just sit here in a circle, and it will call toString, and it will jump into this method, which will then call toString, and it will just continually recursively call itself. When what you actually wanted to happen was to call the toString method, which is a part of the student class, and then concatenate to it what we wanted to add now that this is an undergraduate class. So since we overrode the method, right, we're not overloading it, we're overriding it. So since we're overriding the toString method, when we have this declaration, which has the same return type, same name, and same parameter list as the toString method in the superclass, anytime we refer to the toString method without using the super keyword, Java is going to assume we're talking about this toString method. If we were overloading it, then we would be adding a new version, which would have to have a different either return type or parameter set, right? So don't get confused between overloading and overriding. This is overriding, which means that from this point on inside this class, if we use the toString name, Java is going to assume we're talking about this new toString method, which we defined to override the toString method that was part of the superclass. However, if we do intend to actually call the superclass toString method, we'll have to explicitly tell Java we want to use the super.toString method, and then it will know what we're talking about. So here's what we're saying. In the person class, there exists a toString method. However, in the student class, which extends person, we overrode this initial toString with a new toString method. So anytime inside the student class, where we referred to toString without using the super keyword, this version of toString was called. So then in our undergraduate class, when we again defined a toString method with a return type string, name toString, and empty parameters list, we overrode the toString method in the student class. So now, anytime we use the keyword toString inside undergraduate, we're going to be referring to this toString method. If we want to refer to this toString method, we have to use the keyword super. Again, take a moment to answer this question as well. If that's true, why don't we have to use the super keyword to call the reset method, which is part of the student class? Well, in this case, we are not overriding the reset method. We are overloading it. Notice, this reset method has the same name, so the reset method from the student class has the same name as our new reset method, and they have the same return type, but they have different sets of parameters. So therefore, this is a overloaded method, not an overridden method. So both these methods are still visible, and Java will still allow you to call both of these methods without the super keyword involved. So to call the inherited reset, we don't have to use the super keyword because it's not been overridden, it's just been overloaded. So by using the right number of parameters of the right type, Java knows, hey, you're wanting to call the super reset, the reset method that you inherited from the super class, the parent class. So the example here is that we have overloaded the reset method. So we have a reset method defined in our student class, which accepts a string and an integer and returns a type void called reset. Then we also have a reset method in our undergraduate class, which is called reset and returns a type void. So those match and they're the same. However, it accepts a string, integer, and a third parameter, integer. So since this does not have the same parameter set, Java says, oh, you don't want to override this method. You want to add another method of the same name, which will have different functionality, and I can tell the difference based on the parameter set. So see how this chain of derived classes allows us to reuse and improve the efficiency of our code writing. So this is referred to as multi-level derived classes. Every undergraduate is a student, and every student is a person. Also, every undergraduate is a person. So if we were to call instance of, if we said some object which is type undergraduate, instance of student, that would be true. Undergraduate instance of person, that would also be true. So in this way, an object can have more than one type simply because we may have some sort of inherited class or inherited type that could be considered either a student, person, or undergraduate. Because, as we said, this undergraduate is a student, and this undergraduate is also a person because a student is a person. So by understanding that an undergraduate is a student is a person, we understand that an object of type undergraduate can also be considered an object of type student and also be considered an object of type person. So we can substitute a reference to an undergraduate for a reference to a student or a reference to a person. So then we can consider an undergraduate type to also be a student type or a person type. So therefore, an object of undergraduate type actually has multiple types. And this idea of having multiple types is referred to as polymorphism. So then the payoff is this. If in some method we expect to see a person type object passed in as a parameter, we could instead pass in an undergraduate type object because an undergraduate is a person.